Imagine, if you will, a world where robots aren't stuck with the same old set of legs, day in and day out. It's like a human being forced to wear the same pair of shoes for their entire life, whether they're going for a marathon or attending a fancy dinner. The sheer monotony of it all. But what if our metallic friends could, with a few clever clicks and whirs, swap out their clunky treads for nimble, springy stilts, or perhaps even a set of elegant, multi-jointed appendages for navigating treacherous terrain? The very notion tickles the fancy, doesn't it? So, the burning question remains: is this leg-swapping, joint-customizing robot utopia actually within our grasp? Or is it just a whimsical fantasy best left to the realm of science?
Before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support.
Hold on to your hats, because the answer, in its glorious complexity, leans heavily towards a resounding yes. With a few caveats sprinkled on top like robotic sugar, the idea of removable and customizable leg joints isn't just some far-fetched dream. It's an active area of research and development in the ever-evolving field of robotics. Think of it as the robotic equivalent of Lego bricks, but instead of building spaceships, we're crafting adaptable locomotion systems. Now, let's delve into the nitty-gritty of how this technological marvel might be achieved. The secret sauce, as with most things in the 21st century, lies in a clever combination of hardware and software innovations. At the heart of it all, we need standardized interfaces. Imagine a universal docking mechanism, a bit like a high-tech quick-release coupling, that allows different types of leg segments and joints to be easily attached and detached from the robot's main body. This interface would need to handle not only the physical connection but also the transfer of power, data, and potentially even fluids if we're talking about hydraulic or pneumatic systems. It's like ensuring that any appliance you plug into a wall socket receives the right kind of electricity. Only here, the stakes are a bit higher, involving the variability of the robot to move and function. Then comes the question of the joints themselves. The beauty of customization lies in having a variety of joint types available. For instance, a robot might need simple hinged joints for basic walking on flat surfaces, but for navigating uneven terrain or climbing stairs, more complex multi-axis joints, perhaps mimicking the flexibility of a human ankle or wrist, would be essential. We could even envision specialized joints with integrated sensors for detecting slippage or applying precise amounts of force. Think of it as a chef having different types of knives for different tasks. Each joint type would be optimized for a specific kind of movement or interaction with the environment. The technology to make these interchangeable joints a reality is already bubbling in various research labs and tech companies around the world. Advanced actuators, which are the muscles of our robots, play a crucial role. We're seeing advancements in electric motors, particularly brushless DC motors, which offer high power-to-weight ratios and precise control. For tasks requiring immense strength, hydraulic or pneumatic actuators might still be the go-to choice, though they introduce the added complexity of fluid management. And let's not forget the burgeoning field of soft robotics, which explores the use of flexible materials and fluidic actuation to create more organic and adaptable movements. Imagine a robot with legs made of interconnected, inflatable chambers that can change shape and stiffness on the fly. It sounds like something straight out of a sci-fi movie, but the research is very much underway. Furthermore, the development of sophisticated control systems is paramount. Simply having interchangeable joints isn't enough. The robot needs to know how to use them effectively. This involves advanced algorithms that can recognize the type of leg configuration currently attached and adapt the robot's gait and movement patterns accordingly. It's like a skilled athlete instantly adjusting their running style when switching from track shoes to hiking boots. This level of adaptability requires robust sensor feedback, allowing the robot to perceive its environment and make real-time adjustments to its movements. Inertial measurement units, IMUs, force sensors, and even vision systems all contribute to this crucial feedback loop. Now, where's the juicy gossip, the latest buzz in this exciting field? Well, recent research has been focusing heavily on modular robotics. The idea is to create robots composed of interchangeable modules, including not just legs but also arms, torsos, and even heads. This Lego-like approach allows for incredible versatility, as a robot can be reconfigured on the fly to perform a wide range of tasks. Imagine a search and rescue robot that can transform from a wheeled vehicle for covering large distances to a legged robot for navigating rubble-strewn areas, simply by swapping out its modules. Several universities and companies are actively exploring this concept, developing standardized interfaces and control architectures that would make such transformations seamless. Another exciting area is the intersection of robotics and 3D printing. Imagine being able to custom design a robot leg joint tailored to a very specific task and then simply printing it out on demand. This level of customization could revolutionize how robots are designed and deployed, allowing for highly specialized solutions without the need for expensive and time-consuming manufacturing processes. We're already seeing examples of 3D printed robot components, and as the technology continues to advance, it's not unreasonable to envision a future where custom robot limbs are as easy to create as printing a document. Furthermore, advancements in materials science are playing a crucial role. We need materials that are strong yet lightweight, capable of withstanding the stresses of robotic locomotion while minimizing energy consumption. Researchers are exploring advanced composites, lightweight alloys, and even bio-inspired materials that mimic the properties of natural tissues. These material innovations will be essential for creating durable and efficient removable and customizable leg joints. Of course, the path to a truly versatile, leg-swapping robot isn't without its hurdles. One of the biggest challenges is ensuring the robustness and reliability of the interchangeable joints. These interfaces need to be able to withstand repeated attachments and detachments without wearing out or losing their integrity. They also need to be sealed against dust, water, and other environmental contaminants. Ensuring seamless power and data transfer across these interfaces is another significant technical challenge. Another consideration is the complexity of the control software. Managing a robot with a potentially vast array of interchangeable leg configurations requires sophisticated algorithms that can handle the different kinematics and dynamics of each setup. The robot needs to be able to accurately perceive its current configuration and adapt its movements accordingly, all in real time. This requires significant computational power and advanced artificial intelligence. It's fiction. Well, despite these challenges, the progress in this field is undeniable. We're seeing a growing trend towards modularity and adaptability in robotics, driven by the increasing demand for robots that can perform a wider range of tasks in diverse environments. From warehouse logistics to disaster response, the ability to reconfigure a robot on the fly offers significant advantages in terms of efficiency and versatility. So, to circle back to our initial question, is it possible to have removable and customizable leg joints on a robot? The answer is a resounding yes, and the technology to make it happen is rapidly evolving. While we may not yet see robots casually swapping out their legs like we change our socks, the underlying principles and technologies are very much in development. The future of robotics is looking increasingly modular and adaptable, promising a world where our metallic companions can truly tailor their locomotion to the task at hand, whether it's a gentle stroll across a manicured lawn or a daring climb up a rocky cliff. And who knows, maybe one day we'll even see robot fashion shows, showcasing the latest trends in robotic leg design. Now that's a thought to ponder with a smile. Thank you for joining us on this journey. Let's continue this conversation in the comments below. If you like the video, please Please hit the bell icon to get notified and don't forget to like, share, and subscribe for more insights. See you in the next video. Till then, goodbye, take care, and stay safe.